Hi, I'm Dirk Ducharme, Editor-in-Chief of Quality Digest. I'm in Costa Mesa, California for Capture3D's Measurement Innovation Conference. Capture3D represents GOM's line of 3D measurement equipment, the ATOS scanner and the Tri-Top photogrammetry products. Now, typically when we talk about 3D scanning, we do so within the context of product part verification. You fabricate a part, you scan it, and you compare it to CAD. We don't often discuss how 3D scanning is used much earlier in the manufacturing process. So one very interesting presentation came from Bruce Williams, Head of Quality for Chrysler's Press and Die Shops. I caught up with Bruce after his presentation and asked him to describe how ATOS 3D scanners are helping Chrysler ensure the quality of their sheet metal fabrication process. So Bruce, tell me a little bit about how 3D scanning helps, improve process and reduce cycle time and that sort of thing in sheet metal fabrication, sheet metal die development. What do we call that?
Well, it's a little bit of both. We actually start right up front in the product design office, where we actually take the surfaces of the parts and make sure aesthetically that they're going to work actually in the product itself, and then translate that into a die design. So we're using scanning even way up front in product development. From there, we really take a look at the die design itself, and throughout the build process, we're using scanning to validate at certain steps through the process that we're actually achieving the goal. The goal being the ultimate product model that we started with. So from a very high level perspective, how has scanning helped? It's reducing our time to market, or number of quality loops that we have, as well as it's helping us achieve our overall dimensional goals. And really it's with the partnership of team members like Greg Ankeny, who actually do the useful work on the shop floor. We're able to take that information and very quickly use it to our advantage.
So you're actually measuring a die after it's been initially fabricated, or what's actually?
Absolutely. So we actually scan all the dies. We'll actually start with the draw die and then do the subsequent line dies right in the manufacturing process. So after casting, we'll scan it after the machining process to make sure that the machining actually meets the intent of the product model. And then when we're done from there, through the 3D blocking and so forth, when we're done there, we actually get to first panel the gauge, which is the first time really that the die works, okay, and you get the first part out. We'll scan that first part and make sure that that part is produced as intended. So really throughout the process, and it doesn't just stop there through die construction. It really translates right into the production environment. We're ongoing in our plants. We're also using scanning to our advantage to actually measure the parts on an ongoing basis as well.
Okay, and when we're talking about a die, dies can be quite large, right, and quite heavy?
Oh yes, absolutely. If you think about a roof outer die, for instance, a roof outer die typically, and I'll give rough numbers right now, I don't want to name a specific program, about 45,000 pounds roughly, and I'd say anywhere from 6 to 7 feet by about 12 feet long, so relatively large.
So that's a lot of material, and,
yes.
and is one of the concerns, obviously you want to reduce cycle time, but is one of the concerns, obviously with a die this big, you don't want anything to go wrong. I mean, is it possible in the past that automotive sheet metal fabrication might have to scrap a die or rework a die in the process of developing one?
Certainly a lot of things can happen in die design and development. Typically what would occur is you'd have an extended quality loop or a number of quality loops to achieve the dimensional objective. So with scanning, we're able to validate it throughout the process and reduce the number of quality loops, as well as reduce the time and save costs. So what used to take an exorbitant amount of time now takes very little time. And ultimately you have to get to market as well, as we discussed earlier. So there becomes a cutoff point where you might have to go into more of a functional build. In the past, now we don't have to do that.
Okay, well thanks Bruce, I appreciate you taking the time with us.
Thank you.
Okay.
Nice to meet you.